Every single company is trying to use AI to be as productive as possible. They kind of neglect the security impact of that.
This guy found 30 plus vulnerabilities across all the major AI coding tools. Meet Ari Mazuk, an AI security researcher. He works at Microsoft as a senior security researcher. In this exclusive interview with IDESaster magazine, we'll spotlight Ari's latest research, which recently uncovered security vulnerabilities in 10 plus market-leading products affecting millions of users. He called it IDESaster. We will also discuss why AI-integrated IDEs pose unique security risk and how developers can stay ahead in an AI-driven world.
The biggest attack vector, they all start with prompt injection. Because AI and AI agents and security for AI is so new, some people fail to fully understand what's the attack surface, what's the security boundaries. The most shocking thing that I discovered is every single IDE that I tested was vulnerable.
I've been thinking about the way this whole thing has been evolving and how many developers consider AI assistants as their most competent hand, and some of them just leave them to perform tasks with almost no supervision. How dangerous could this be?
Do I actually have to answer that? I think it's pretty obvious, right?
Ari Mazuk, welcome to IDESaster magazine.
Thank you. It's great to be here.
It's our pleasure. Now, it absolutely blew my mind when I saw in your report that 100% of tested applications, and by that I mean AI IDEs and coding assistants integrated with IDEs, were vulnerable to IDESaster. Can you explain the new IDESaster attack chain and specifically highlight how it's different from, say, the prompt injection techniques that we are already familiar with?
So IDESaster doesn't actually focus on the prompt injection vector at all. Prompt injections are there, and we can't entirely prevent them at this point.
Mm-hmm.
So I decided to leave them aside and focus on what's their impact. The way that IDESaster differs from other previously reported vulnerabilities is the fact that it's universal because it focuses on the IDE layer and not on the specific agent. Then if you find something, it applies to every single IDE that uses that same base layer.
That's crazy. Give us a bit of a peek into that before we even get deep into the conversation. Give us an example of that sort of base layer finding that we just cut across.
One example would be if we're looking at Visual Studio Code, it has a specific feature that's called remote JSON schema. It's supposed to let you load a JSON schema for development usage, which basically helps you check that your JSON fits a specific syntax that's specific for your application. But an attacker that is able to edit files with the AI agent can actually abuse that to exfiltrate information with a GET request.
Whoa. Okay, so let's go deeper. I want you to describe to us how large the attack surface is when you run the average agent coding tool.
When we first look at agent coding tools, the first obvious attack surface is the tools that it uses. Tools are things like editing files, writing files, reading files. It can also be executing commands. Sometimes these tools are properly implemented, and other times they are not, and you're able to find a vulnerability in one of the tools themselves and abuse it to get code execution or any other impact. But the attack surface is actually bigger than that, which is something that IDESaster showed, is that when you connect an AI agent to the IDE, another attack surface is the IDE that you connected the agent to. Because this IDE was built before AI agents existed, and some features weren't built with those AI agents in mind, which basically creates a huge attack surface because every single IDE feature might be your next vulnerability.
So talking about vulnerabilities, I know one or two vulnerabilities will be scary, but 30 plus is super scary. So in your opinion, why do you think the developers behind these IDEs fail to anticipate a risk introduced by AI agents into developer environments?
I think possibly the number one reason is how fast we're going with this world. Every single company is trying to use AI to be as productive as possible. And then they kind of neglect the security impact of that because we're just running as fast as we can to beat the competitors. So this is something that companies have to consider, like what's the actual impact of adding, like what's the actual security impact of adding an AI agent to an existing application or software, taking something that existed before that was safe up until this point, assuming that it was safe up until this point, which is might actually be true. But then connecting the AI agent actually changes the attack surface and changes the threat model in a way that was unpredicted.
Absolutely. So another thing that blew my mind while reading your report, because I definitely did read it, right, is that you explicitly chose to withhold the exact exploitation prompt because several vendors, despite a standard 90-day responsible disclosure window, which you have observed, and they have acknowledged the vulnerabilities, but they have still failed to fix them. Does this significant lag in remediation suggest that the industry is underestimating the severity of IDESaster, or does it really just signal that decoupling AI agents from legacy IDE features is maybe a much more complex architectural challenge than we previously realized?
I think the right answer is kind of both.
Okay.
It's both the fact that the solution to this is not trivial. Unlike a traditional vulnerability, this is a vulnerability class. So it's not like a single fix can handle all the cases of these vulnerabilities. And the other thing is because AI and AI agents and security for AI is so new, some people fail to fully understand what's the attack surface, what's the security boundaries, and that kind of makes it so I'm not going to say underestimating the severity of IDESaster, but potentially not even understanding it.
And that's a different type of problem there.
For sure.
Yeah, when you don't understand it, it's different from when you underestimate it. Because to underestimate, you sort of get a good enough understanding, but not with context enough to have the sort of urgency you need to attack it, correct?
Yeah, that's right.
Yeah. So, but given the sheer volume of CVs, these days you receive CVs, acknowledgement and assignments, and you're not sure which you're receiving it for. And just the nature of these flaws, are current vendors patches enough, or is the AI as a plugin model fundamentally broken? And does it really just require us to build IDs from the ground up again?
I would say that rebuilding IDs from the ground up with what I called secure AI, which is a new security principle that I coined, is the right approach to fully mitigate or significantly mitigate this vulnerability class. But the biggest problem is that it's a lot of work, right? So building an entire ID just for that would possibly make it delay a lot. And then you know how companies first try to get customers.
Yes.
Like they try to sell their product before thinking about the security implications of it.
Mm-hmm.
And then the impact of that is that they are basically rushing to integrate AI in their software. And then I don't really think that rebuilding the IDs from the ground up is something that's going to happen in the short term, but it is definitely something to consider for long term, right? So maybe we'll see some next year or something
Okay.
this year.
Okay, fingers crossed on that one.
Yep.
Again, back to your blog post, and I'm going to come back to your conversation, what you've just raised about secure for AI, because I found that very interesting that you coined that. But you also mentioned in your blog that some of the vulnerabilities you uncovered could lead to unpredictable risk like data exfiltration and remote code execution, which you've already hinted on this conversation. Can you walk us through one of the attack chains that best explains how, this could escalate to full-blown exploitation of base ID features?
So, as I said earlier, there are a lot of AI IDE, like IDE features, right? I personally don't even know all of them. And there are also a lot of IDEs. There isn't just a single one. I'll take one example that was in my blog, right? If we take a look at the Visual Studio Code settings file, right? It lets you define settings for your base IDE, basically. But some of these settings can lead to arbitrary code execution. One example would be if you set something like your PHP path, which is used to validate the syntax of PHP files that you're writing as part of your IDE, then you can basically point it to an arbitrary file. Now, that arbitrary file could be a file that you wrote yourself and is malicious. So technically, in this way, if you overwrite the PHP path to a file that you wrote, and then you're basically just creating any PHP file, then that automatically triggers the PHP validation, which then runs your malicious executable in this case. In this case, the impact would be remote code execution, which I would possibly consider the worst impact that could be.
Okay, I know that could be one of the 3 case studies you shared in your blog post. Can you walk us through the other 2?
Yeah, sure.
I want people to be able to get like a good picture into what these scenarios are like.
Sure. So another example would be the fact that with Visual Studio, as an example, you can create a multi-root projects, which are basically projects that consists of more than one folder. Let's say you have 2 folders that you're trying to use at the same time, you're editing 2 projects or something. Then in this case, your settings file changes to something else. So it's no longer the VS Code settings file, it's now a code workspace file, which can have any name, by the way, because the user can save it under any name. And that basically makes the mitigation of the first attack chain or case study obsolete, because what that does is if you blocked write access to the VS Code settings file, but now you're using a new project that has 2 folders, then it's no longer the VS Code settings file that controls your environment. It's now another file. And again, that's one feature of the IDE, the multi-workspace projects. And the other one, which we also mentioned earlier, is the JSON schema, the remote JSON schema that should let you load remote JSON schema to validate your JSON, but an attacker can use that to exfiltrate information without user interaction, which is typically needed when you're trying to make a web request through an agent.
That is mind-blowing that no user interaction is required for these to happen. I'm going to have to need to process that because that's very scary. That is mind-blowing. And I still want us to double down on your research. I want you to tell me throughout your research, what was the single, maybe most shocking discovery you made? Whether it was a specific technical feature being abused or a human weakness that attackers could exploit. What was maybe the most shocking thing you saw?
I think the most shocking thing that I discovered is the fact that this is a universal exploit for all the IDEs, right? Every single IDE that I tested was vulnerable. And I think the reason for that is the fact that you're taking something that was not vulnerable before, and it basically turned into something vulnerable whenever you added the AI agent. So those are the IDE features. And this is something that I don't think I've ever seen in any research, because typically if something is not vulnerable, then it's not vulnerable.
Yeah.
It's not suddenly turning vulnerable, right?
Yes. And I like that you actually gave it like a very unique name, because that is, when I read the report, I had goosebumps, like literal goosebumps. Like
that took more time than the research, choosing the name.
Right? What? Tell me the story behind the name. Is there a story behind the name?
So I was thinking about a cool name, because it rings better.
Yeah.
And of course I used AI because why not, right? I basically took ideas from like an LLM until one of them popped out. This is the one.
Which of them, if you don't mind sharing?
I think it was ChatGPT.
Oh, interesting. Okay.
Yep.
All right. You mentioned some vulnerabilities that are related to Model Context Protocol, called it for short MCP, and vulnerabilities such as rug pulls and tool poisoning. As MCP really just gains adoption as a standard for connecting AI to data, what specific safeguards should developers implement with the MCP servers or prioritize to prevent them from becoming a backdoor?
So MCP is pretty interesting because it's not the vulnerability itself, obviously, but it is the attack vector. Basically, that could be an attack vector like the prompt injection we were talking about earlier. And I think something developers often overlook is first, an MCP server that you connected to, even if it was a legitimate server, can turn into a malicious server if the developer just decided to change it, or if an attacker hacked into that MCP server. So even an official MCP server, right? Imagine that a hacker breached one of the official MCP servers that are used by millions, and then he changed it with an attack like this, right? That affects millions of users instantly.
Just like NPM packages.
Yes, exactly.
Oh, my days.
So what should we do to prevent that from happening?
It's like an upstream problem.
Yep, it is. So how do we prevent that? I think first is only using whitelisted or trusted MCP servers. That's pretty obvious. And the second thing is monitoring them, which is something I don't see people do often enough. Because again, even an official safe MCP server can potentially be breached, right?
Yeah, but this whole thing about when you said something like trusted, that's become so subjective, and it's difficult to even know what's trusted as an MCP server. What are your recommendations around that?
If you want to be fully safe, I would say go look at the MCP server, understand what it actually does, what are the tools, what are the capabilities, what are the descriptions of those tools, and finally, who is behind that MCP server? Do you trust that person to not change it tomorrow?
Those are some very, very good pointers. But let's go back in and talk about your Secure for AI principle, which you mentioned in your report. You said the concept of Secure for AI is distinct from secure by design. For a developer currently building, say, an AI tool on top of a legacy platform like VS Code that you've mentioned, what is the single most critical architectural change they should make today to align with this principle?
The first thing I would say is that Secure for AI, right? The concept behind that principle is that building even those legacy systems, right? But it's impossible now, but building any new platform or application should be built with a potential AI agent that will be added in the future, because that's something that's happening a lot now.
Yeah.
So when those legacy platforms were built, no one thought about AI and AI agents. But now, every developer that is building an application has to think how and what I should build to make sure that this is protected whenever an AI agent or any AI integration will be added to that. And if we're talking about the most critical architectural change that we should change today to align with this, that would be trying to minimize the autonomy of the agent. It's problematic, right? Because that's how it's supposed to be used to actually be productive. But again, that's my best advice now, because again, the Secure for AI principle, what it's there for is not to prevent vulnerabilities when AI agents are added to old legacy software, but actually to prevent your new software from becoming the next legacy platform that's affected.
But again, I want us to really zoom in, because I don't think we've really done justice to Secure for AI principle. We've danced around it a bit. What is Secure for AI principle? Discuss that.
So the Secure for AI principle basically says that whenever you build an application, you have to both build it obviously secure by design and secure by default, but you also have to consider an AI agent. So let's take an example. Whenever the JSON schema feature was built into Visual Studio Code, right? It is enabled by default because they assume that whenever a user can edit a file, I don't mind that a GET request is happening because someone's already editing a file on my system. But then when AI agents were added, then should it actually be enabled and by default? I mean, that makes it so any AI agent can leak information instantly.
I get it now. So let's assume a developer is watching this, I want you to share some mitigations for developers that are building AI IDEs. What is the most important step they should take to mitigate IDESaster's risk and why?
So I would say the right approach is defense in depth, right? So it's not a single thing, but it's more than one. The first thing is trying to prevent prompt injections, which is not always possible, but it is sometimes your responsibility. Like the information that you're using, the project that you're opening, the MCP servers that you connect to, all of those things, they can lead to prompt injection. And then with a vulnerability, the impact is worse. But preventing the prompt injection prevents the vulnerability, right? So that's the third thing. The second thing, if we're talking about developers that are building the AI IDs, because the first recommendation was mostly for people that are using them, is first, when you're building the tools, make sure they're not vulnerable to the classic vulnerabilities. When I say classic, I'm talking about vulnerabilities that were there before AI, right? So command injection, path traversal, stuff like that, because these are things that I've faced too many times, to be fair.
Yeah.
And then the other thing is you want the tools to be capability scoped. So every tool, right, has to have a specific narrow set of like an action that it does. It has to be as narrow as possible. So for example, if we take like the write file tool, I would prefer that would write only to an SRC folder, because SRC folder is typically there for source code. It typically won't have settings files, right? So that would prevent the VS Code settings or potentially the multi-project attack chain that we discussed earlier, right? So we want to make sure those tools are secure. That's obvious. And then human in the loop, obviously, is another thing. So letting the user decide whether they want to perform an action or not. So it's not like automatically, autonomously hacking your computer, you know? And then one more thing that we're seeing happening a lot now is sandboxing. It sounds like it's the perfect problem, like the perfect solution, sorry, but it's not, right? Because even with sandboxes, right, some of these attack chains will still work. Because as an example with the VS Code settings attack chain, the VS Code is the application that executes the code here. It executes the command. It's not even the AI agent. So even if you implement sandbox for the AI agent, you didn't do it for the IDE. Because again, it was built before that. Okay, so system prompt hardening is one more thing that's great. It's not going to prevent that, but it is going to make it a little harder for an attacker to actually implement this. Oh, and one more thing is limit the LLM selections. Whenever you're using an older LLM model, it's obviously easier to prompt inject it or make it do malicious things, while often newer LLM flagship models are a lot harder to do that. So that's another thing. A great tip is to always assume that your agent is breached. It's agent assume breach is how I call it. Basically, it follows the zero trust principle.
Yes.
Because if there's prompt injection, right, and you should assume as a developer that it's going to happen at some point, you want the impact to be as little as possible. So don't give the agent something you wouldn't give to an attacker, right? So just like you wouldn't give an attacker the option to execute commands, you don't want to give it to the agent either without user approval, right?
Yeah, but I know you've just spoken a lot and you recommended things like capability scope tools and say strict human in the loop requirements for sensitive actions, right? I'm just thinking about it that the selling point of many of these agents is autonomy. So how do security teams strike a balance where they don't crush the productivity gains of the AI tool, but they still are able to prevent it from rewriting settings adjacent or any other very sensitive action?
That's a great question. And I don't have a magic solution. That's the honest answer. Again, defense in depth is key here. Trying to strike balance with things that you can, right? So something like outbound security roles, right? Firewalls, stuff like that, to prevent requests from going to unknown domains. As an example, you don't expect Visual Studio Code to send a GET request to a random domain, right? Ever. And even if it does, like for a real JSON schema situation, then monitoring that is still a good idea. Checking with the user that they actually did it, or even implementing a human in the loop for reaching out to new domains, right? Like having a kind of a allow list of domains.
Yes. And in this conversation, you said something about monitoring. You said it twice. You just said it now and again. Give us one tip around monitoring that you hope you could see, but you're not seeing. Because you mentioned in this chat that something you're not seeing. You're not seeing monitoring happen. Give us one way that you think this should be done.
There are a lot of ways to do this. The probably obvious part is monitoring for the prompts, right? Because the biggest attack vector, like they all start with prompt injection. If you monitor all the requests that are sent to the AI agent, you would definitely find those prompt injections, especially, by the way, with the most advanced models, because the prompt injections have to be typically longer, more advanced, and it's not just a one-liner, right?
Yeah.
Again, it's not a perfect solution, but it is something.
Okay, does help. I've been thinking about the way this whole thing has been evolving and how many developers consider AI assistants as their most competent hand, and some of them just leave them to perform tasks with almost no supervision. How dangerous could this be?
Do I actually have to answer that? I think it's pretty obvious, right? So just as I said earlier, just assume that the agent is an attacker, because given prompt injection, the attacker controls the agent. So giving it full autonomy is basically giving an attacker full autonomy.
Yeah. But what is the best way to educate developers about, say, the risk of implicitly trusting AI assistants without necessarily scaring them away from the benefits of using AI?
I think the best way to educate the developers about the risks is possibly letting them know about them, like showing them actual examples of how the risk looks like, right? Because it's still relatively new, all the AI agents world. If we looked at today, everyone knows what SQL injection is.
Yes.
I mean, even developers know that, right?
Yes.
Any
developer who doesn't know that shouldn't be writing code.
Well, that's right. So we should say the same for AI agents, right? We should educate developers. Like safety training, I guess.
Okay.
Security
maybe AI
training.
Specific safety training.
Yeah, that sounds good.
Yeah.
Sounds like a good idea.
And you should set that up. Okay, you're busy. But just talking about safety and everything along those lines, I really like what my friend Rob Lambros recently wrote on LinkedIn. He said, and I quote, hopefully close enough to what he wrote. He said, the fix isn't to stop using AI coding tools. The fix is to stop trusting them implicitly. So for the developers watching this video, what are the immediate practical controls that they must put in place today, especially for AI tools that have right access to their code bases?
One thing that we see developers doing a lot, and it's not even a vulnerability, right, is just trusting, not just trusting those agents, but giving them more and more permissions, like enabling everything because it's quicker, because they don't even understand the risk behind it. And that basically makes it a lot easier for an attacker, even without a vulnerability, just with prompt injection, to execute code or hijack your computer. So I think the most important thing to put in place today is not only to not enable everything to autonomously run, but also take it the other way around. Like, go to the settings and disable the things you don't use, right? So even just going and disabling remote JSON schema. If you don't use JSON in your project, why do you even need that? That's just like an attack surface for an attacker. So basically, both disabling features they don't need in the base IDE, but that also applies to the AI agent, right? Don't give it access to things you don't have to give it access. open it in a specific project. Maybe even putting it in a sandbox. Do you actually need this to run on your computer? Or do we want to run this in a virtual machine, right? That could greatly help. Even if those vulnerabilities were not fixed, this limits the impact, right? Because in a virtual machine, that's better.
These principles are literally just legacy security principles that are applied with the context of AI here. Because what you've just described to me is least privilege.
Yep, that's right.
Yeah.
But again, the problem is that because they are so new, it's not that the principle is new, but because AI and AI agents is so new, people don't really understand how to apply.
How you'd apply.
Yeah, exactly.
Oh my days, that is so correct. I also know that you advise users to only use IDs with trusted projects. And you've mentioned it again in this chat earlier on. Realistically, security researchers and developers often just browse untrusted code to audit it. Is there a safe mode configuration you would propose for these scenarios, or should AI features be completely disabled when opening unknown repositories?
I would say that this depends on the specific AI ID that you use because some of them have specific features and others do not, right? One example would be if we're looking at Visual Studio Code, right? It has the restricted mode for untrusted projects. Now, the thing is, in restricted mode, the AI features are disabled. Maybe if you still want to use them, you gotta trust the project. How do you trust the project? Go over it, understand what it does, see that it's not malicious. Just like you won't execute a random executable that you don't know what it's doing, then go ahead and read the code, understand what it does. Especially when we're talking about developers here, right? Because who uses AI IDEs? Mostly developers. They know how to read code. They can go see the project, see if it can be trusted. That's already better than just running it on a random project.
I agree with you. So, given the fact that you found RC vectors involving simple configuration edits like the PHP executable path you mentioned, do you believe that AI agents operating within an IDE can ever be safe without running it in a fully isolated sandbox like you've described? So, a Docker container or a separate VM. Do you think they can ever run by default and be safe?
It's a good question. I don't know how the future will look like, but spoiler alert, even inside fully isolated sandbox, they are not safe. So I haven't published this yet, but I've had a situation. I've had a situation where even in a fully isolated environment, you were still able to basically break out of that environment, right? And then it's not really isolated anymore. So is it really isolated?
It's not isolated enough.
Probably, yeah. So executing malware on your computer is bad, right? Executing malware on a VM, it's better. It's not great, right? Unless you're a malware researcher, and then that's fine, probably.
Hopefully you have the safeguards tightened up so well because you know exactly what malware could still do in a VM environment. So I agree with you on that. I really just want us to talk about the multi-root workspace attack, which you showcased in case study 3 in your report. I want us to discuss specifically the persistence mechanism. You said the persistence mechanism is subtle, right? If a developer suspects their ID environment might have been compromised by, say, a malicious repo that they opened, say, last week, what artifacts or config files should they check first to ensure no backdoors were left behind?
Specifically with the multi-root workspace attack, the file is the code workspace file, right? So the path for that file changes because the user can define that path. So the user can save that file not only under any name with the code workspace extension, but also in any folder. So, I mean, the answer to this is I hope that the developer should know. Because if they use a feature, they should probably know what it does, where they save the file, and where is the configuration file to look for.
We should hope.
Yeah.
We should really hope. Yeah, but that's not always the case, realistically. So I think this is also something that developers need to pay attention to. Traditional SaaS and DaaS tools typically look for code flaws, but IDESaster exploits logic and legitimate features from what you've described to me so far.
Mhm.
How can security professionals write detection rules or monitoring scripts to catch an AI agent attempting to exploit these specific legitimate IDE features?
The real answer is that logic vulnerabilities existed before, right? Even before AI vulnerabilities. So it's something that's obviously harder to prevent. And in this case, it's a little easier, I would say, because one way would be to detect the prompt injection attempt.
Yeah, you mentioned.
That's a great way. But again, that could also be written in a way that sounds or looks legitimate. And there isn't a perfect way to do this. Maybe just like monitoring the parameters that are sent to tools. Maybe even leveraging AI, like asking an AI, right? Is this flow of tools, tool calls, or parameters? Does it look suspicious? What is it trying to do? Because, as an example, right, reading an SSH key and then creating a JSON file with a remote JSON schema with that SSH key as part of the URL, technically it's legitimate IDE features. But obviously, if you go and ask an LLM, it's going to say that it is potentially, possibly, very likely malicious.
Yeah.
Maybe the right way is using AI, right?
Yeah, using
AI against AI.
Yes, AI. So you mentioned earlier that system prompts and LLM selection are part of the mitigation strategy, but not a cure all. In your testing, did you find that smarter models like Claude 3.5 Sonnet or GPT 4o were harder to trick into these exploit chains, or did their increased capability actually make them more effective at executing the complex multi-step attacks you described?
Honestly, if the prompt is accurate enough, then even the older models can follow the so-called complex multi-steps attacks. You just gotta know how to properly build a prompt. That's just like a lesson in prompt engineering, right? But they are definitely trained a lot to not do harm. Like, this is something that's very obvious with every LLM company. Everyone is trying to make sure that their LLM model is safe. It's not doing anything malicious. And I think it's making it harder rather than making it easier in this case for an attacker.
Nice. So I know being an Oliver Twist right now, but you said we should keep our eyes peeled for your next research. And you've already given us some breadcrumbs here, but we want more. We want more. What should we be expecting to see? Please leave some more breadcrumbs for us. What should we be expecting to see in your next research?
I have a few leads. It's not something specific. I am obviously looking at the most prominently used AI applications today, right? So one of the newer things is AI browsers. They are heavily used and it's very new, right? So that would be a great research lead.
Okay.
So possibly something in that world.
I like the sound of it. I'll keep my fingers crossed for it. I put out a tweet before our chat and I asked for questions. I solicited questions from people, wanting to chip into this conversation. And some questions were sent in. So I'm going to read some of them and then we'll have a go at them. So Ali Hoe is asking, what commands should humans approve the coding agents to run? And are humans better decision makers than models? Is there a way to securely set up coding agents so humans can trust them to run the right commands?
Humans are definitely better than models, not because models are bad, but because models can be prompt injected into deciding something else. Even if the model itself is great, right? If I can change the decision, then it's no longer great. Not because it wasn't great before, but because it's no longer great. So it's just like making a compromised brain make the decision, right? I would definitely say that it's great to make sure that you make the decisions yourself. Then for the second part of the question, as I said earlier, you want to give it as little autonomy as possible. If you want to keep it secure, yes, it does hurt your productiveness, right? If you want to run it more autonomously, like be more productive, then perhaps run it in a VM or a Docker or something where the impact is little, just like how you would run a malware, right? In this case, if you run it on your computer somewhere that you don't want hacked, then in this case, I would say give it as little privileges, as little auto approvals as possible, and make the decisions yourself for everything. Because if we'll take a look at my 3 previously released attack chains, you can see that all of them used writing files, because all the AI agents allowed writing local files instantly, like no approval needed. Because when I say local, I mean in this workspace, in the workspace that we're currently using. Because obviously, if you use that, you want it to write files to the current workspace. But that also leads to leaking information, editing the configuration files, making malicious commands run because of editing those files. So just disabling the auto approval for this write
Yeah.
would make it so you could prevent that.
So someone else is asking, Sue is asking, how is AI helping with discovering vulnerabilities?
I did use AI in some of my research, both to find leads. It's a great way to automate things. So just as an example, at one point, it was after I already found the remote JSON schema vulnerability, but it was Claude back then, Claude Code, and I used it to try and see if it could figure it out by itself, right? And I basically let it run repeatedly to see if it could make the IDE simply make a GET request creatively, obviously. And at one point, it did figure out the remote JSON schema.
Whoa.
Yeah, so that would obviously change with a prompt injection and reading files. That would be technically a vulnerability.
Was that before you found it or after you found it?
It was actually after, because I wanted to test if it could find it. But it's a great example that it's possible. And it's something that's already happening, right?
Yeah.
People are publishing a lot about it.
Yeah, that's awesome. Another question here from Wick. Wick is asking, what are the common patterns across tools? Real world credential leak mechanics, which vendors fixed fast versus ignored.
Yeah, so I'm not going to talk about vendors because some of them didn't even fix, and that's a bad thing to say.
Exactly.
Yeah, I don't want to crucify anyone.
Yeah, plus you have also mentioned about common patterns across tools anyway, right? You've already answered that question. So we can move on to the next one. Cybergirl Ace is asking, which vulnerability was the most common across the tools? What should developers do today to reduce risk when using AI coding tools? You've already answered that bit. Do you expect the number of vulnerabilities in AI coding tools to increase or decrease over the next 2 years?
For the second part, if I expect it to increase or decrease, I would say increase, but not necessarily because we make them insecure, but because there are so many new AI applications and AI integrations that are added to applications. So we will definitely see an increase in the amount of AI vulnerabilities found generally as a trend. So about the first part, we were talking about the most common vulnerability. So that would definitely be, it's actually a vulnerability that is not even part of IDESaster, right? But one of the most obviously dangerous tools is the execute command tool, right? It has a different name for any agent, but almost all of them had some kind of auto approval that can be defined either by the user or by default. So either safe commands that are automatically allowed, or commands that the user can make auto approve as part of their settings. And I've had a lot of vulnerabilities basically bypassing that, injecting additional commands. So command injections, I can't believe I'm saying it in 2025, 2026 actually, but command injections were actually the most popular as part of those code execution tools. Yeah, that's crazy.
That's mind-boggling.
Yeah, I think it's because people don't really understand the attack surface yet because it's so new and they rush to release things.
Are we training
Yep.
enough? Or are we
I'm not sure.
Yeah, because it just comes back to that. In fact, there's an article coming out in this issue that we're publishing this chat that you and I are having, which is the AI Cyber Winter 2026 issue. And one of the articles says if you can't threat model it, you can't secure it.
Yep.
And I'm really looking forward to people reading that and also watching this interview, because it just seems like we're not threat modeling it well enough, or we're not even threat modeling. It's really scary. And I want to take the last question now. It's from Sumi. She says, oh, this is really interesting. Would love to know if any of the vulnerabilities were specific to MCP server integrations, or if there were more in the core tool architecture itself. The way these tools connect to external services feels like such a big attack surface. We've already just really dissected that. But is there anything you want to add to that?
Yeah, sure. I'll add something. So, one popular vulnerability with MCP that is specific to MCP, again, not really related to the IDESaster research, is that the MCP configuration, that's something that I typically consider part of the agent and not part of the base ID because it wasn't there before. But we do see this coming into IDEs because, as an example, MCP support was added to Visual Studio Code. So we might see that coming more and more. So editing that MCP configuration file lets you define MCP servers. If you define a local MCP server, some AI agents would execute that MCP server because they are trying to connect to it. But if you can edit the configuration file, you can basically put any arbitrary command to be your MCP server. Because if you edit the file, you decide how an MCP server command looks like. So this is something very popular. It was published multiple times before in multiple vendors. So this is like one attack surface of MCP. But I mean, I'm sure we will see more as time goes.
I'm sure we will as we get to learn more about AI. Thank you so much, Ari. I had so much fun clearly chatting with you. And I'm sure everyone that's going to get to watch this video, would not just have so much fun as much as I have. Yeah, that's given. But would also learn a lot and basically take these learnings and improve the environments and the innovations that I'm building and securing. I'm very excited and I can't wait for people to get to watch this episode. Thank you so much, Ari, for your time.
Thank you so much for having me. It was great. I had a great time. Thank you so much.
All right. Bye for now.